How's it going, everybody? In this video, we're going to go ahead and take a look at our next topic when it comes to the Layer 2 section by focusing on port channels or link aggregation. So we're going to be taking a look at all three protocols, or I should say LACP, PAGP, and then turning it on for situations where protocol negotiation isn't needed or not available. Now, one of the key things here about link aggregation, port channeling, ether channels, whatever term you want to use, they all mean the same thing really, is to be able to better utilize the link connectivity between the switches. Where, for those of you that are comfortable with spanning tree protocol, once it is figured itself out and it's deployed, it blocks a port, right? And that blocking of the port is where people are going to be like, they're not going to like that, because that's going to slow down the network. It's going to cause bottlenecks in the network. Reconvergence is going to have to kick in. So it's better to migrate away from spanning tree protocol in scenarios where you can. So does that mean that it goes away in the triangle design that we have? No, it does not. It's still going to be there. But if you have a scenario where you are not leveraging spanning tree protocol in a certain design. So an example of what I mean by that, for those of you that don't understand what I mean, is if this connection right here between switch 34 and switch 35, if this was changed into a routed connection, so if this was not a port channel, this was two interfaces, or maybe it was a port channel and it was layer 3 and there was no spanning tree protocol going on between here. If there's no spanning tree protocol going in between the switches, then spanning tree exists between here and here and here and here, which means that both links would be active, right? Because there's active forwarders going north and south. It's when you have this connection right here still enabled at layer 2, where you could potentially still have the never-ending loop. And that's where spanning tree protocol is going to have to kick in. We're not going to actually be relying on that in this particular scenario, but the key thing that comes into play is when you have a triangle design like this, you need spanning tree protocol. So in this case here, where these connections right here would be blocked, right? So that you can have traffic go this way, or you can have traffic go this way, something like that. That's going to give you the capability of moving the network traffic more efficiently throughout the network. So we're going to go ahead and take a look at actually deploying port aggregation and how that process comes into play. Now, I'm not going to dive into the individual protocol level details very much, other than to show you guys how to configure them, because there's documentation that you guys can go look up. But at the end of the day, you have LACP, which is an 802.3 AD, which is an open standard protocol that every vendor that's out there can run. VMware runs it, Cisco runs it, Juniper runs it. PAGP, port aggregation protocol, is Cisco proprietary, meaning that you need Cisco boxes on either side. So not very widely deployed. As a matter of fact, almost every environment that I've ever worked in, it's LACP. Then you also have the ability of turning it on, which means that you don't use a negotiation protocol. You simply enable port channeling on a couple of interfaces and you're good to go. When it comes down to the specifics to port channels, the interfaces have to be the same, meaning that if you're going to be running gigabit interfaces, that both interfaces need to be gigabit. So one can't be set to 100 meg and the other one's set to be gig. That will not work. You need to make sure that the interfaces are the same speed and the same duplex. So gigabit full duplex, things like that. Beyond that, that's pretty much the main thing. Cisco does recommend that you bundle in groups of 2. So 2, 4, 6, 8, whatever the availability is for that particular switch. Lower model switches will be unable to aggregate more links. But one key thing that I want to talk about before we actually dive into the config is the aggregated bandwidth that you see. So if I have 2 1 gig interfaces, that's 2 gigabits of aggregated bandwidth, right? Because you got 2 1 gig interfaces. Does that mean I can send 2 gigabits of traffic over that link? No, it does not. What that means is, even though we have this link here and this link here are both 1 gig, I am able to send traffic over both links at the same time. I'm able to load balance traffic over one link and then other traffic over another link. What it basically enables me to do is I can send one flow across this link. Oops, that's a bad example. I can send traffic over this link right here, and I can also send another flow over this link right here. The benefit to that is I'm able to load balance the flows over both interfaces. So the key thing here, though, is because we're dealing with gigabit interfaces, the maximum throughput on any one flow is going to be 1 gigabit. Even if I have 4 1 gig interfaces and I technically have a 4 gig port channel, I can only send 1 gig flows, a maximum of 1 gig flows over in a single interface, because the member interfaces are the ones that are actually taking the data and serializing it to the interface and sending it across the wire to the remote end. I can't take a 4 gig, I can't create a 4 gig connection if I don't have a 4 gigabit interface. Now, that goes away when you take a move away from the 1 gigabit interface and you move over to a 10 gig connection. So I have been in scenarios where I have a switch that's deployed between, like for a switch going down to a server, and the server's got like an 8-port NIC, and then I see multiple links going down to the server, and people think that I've got 1, 2, 3, 4, 5, 6 interfaces, that I have a 6 gigabit per second connection. That means I can send 6 gigabits per second, and that is simply not the case. You can't send a 6 gig flow over 6 individual interfaces. You can only send one gig flow over one of those interfaces. So if I need to take advantage of more flows or more throughput, so I need to be able to send the traffic faster, the only other way to do that is to take those individual interfaces that are 1 gig. If the ability to run 10 gig is there, that's what I will do. I'll need to switch from 1 gig to 10 gig interfaces so that I'm moving from 1 gig is my maximum throughput over to a 10 gig interface, which will allow a 10 gig flow. So this means that I go from, instead of doing 6 1 gig interfaces, I go to 6 10 gig interfaces. This changes to a 60 gigabit per second interface so that the maximum bandwidth per flow might be able to use is 10 gigabit. And that's where that comes into play. So just because you see port channels and you see aggregated bandwidth, that doesn't mean you're going to be able to send 2 gigabits per second. That means you'll be able to send 1 gig at whatever the maximum interface speed is. So 1 gig, 10 gig, 40 gig, 100 gig, that's where that process comes into play. So now that we've covered those details, let's go ahead and actually dive into the config a little bit and wrap this bad boy up. So I've got, I enabled on switch 36, I've got some debugs that we're going to be running through as we go through and set this up. I'm going to go to switch 34 and we're going to start this configuration on here. One of the first things that I have to do though is on all the interfaces I have to convert them to be trunk links. So if we do a show interface trunk, you're going to see that I have gig 01 and gig 02. I need to add gig 03 and gig 1/0. So interface range gig 0/3, gig 1/0, switch port trunk and cap.1q, switch port mode is trunk. Do show history. I'm going to take this command these commands right here and dump them onto switch 35 and paste them in like so. And then on switch 36, show interface trunk. Currently, they're working on it. So we have negotiation for 3 and 1. So eventually those should come online once the other ports come into play. So they are negotiating 802.1q, and that'll be fine. So what I'm going to go do now is I'm going to go ahead and start the configuration on switch 34 and switch 35, where we're just going to turn port channeling on. So I'm going to go into, this is, if I hover over this guy real quick, this is gig 2 and gig 1/0. So we'll type interface range, gig 0/2 and gig 1/0. And underneath here, I'm going to type in the channel group number. In this case here, I'm just going to choose 45 because I'm between switch 34 and switch 35. So switch 45, group 45. I'm going to type in mode, and then I'm just going to type in on. Okay? So it creates port channel 45. And if we do show run interface port channel 45, what you should see is that the interface configurations of gig 2 and gig 1/0 are automatically inherited by port channel 45. So now if I go over to switch 35 and I go into interface range gig 0/2 and gig 1/0 and type in channel group 45, mode is on, same thing here. Give that a couple seconds to come online. And then do show run interface port channel 45. Same thing there. Do show ether channel summary. And we can see that we are layered. So based off the output here, let's go ahead and scoot this up just a little bit. And we'll look at the outputs real quick. We can see that capital S means it's layer 2. And it's capital U means it's currently, obviously it's up. This is in use. We can see that the P here means that it's been bundled in a port channel. So we had the very first one done. So we're in good shape. The next one I'm going to go do is on switch 35 down to switch 36. I'm going to do, 34 to 36 first. I'm going to go to interface range gig 0/1 through, and then gig 3/0/3. In here, I'm going to use LACP. So I'm going to type in channel protocol is going to be LACP. Okay. And I'm going to type in channel group, and it's going to be 46. And then I'm going to choose the mode, and I have a couple of options. So I have the option on this side here to be active or passive. If I choose active, I'm saying I want to run LACP out of the gate. I'm going to tell the other side that we're going to run LACP. This is basically, think of this as the initiator. This side, you're saying we are going to run LACP, not where passive is saying if we detect an inbound active message for LACP from another switch, then we'll go ahead and run LACP. Passive is more like, I'll do whatever you tell me to do. Active is saying we are going to do this. Initiator versus responder. So I'm going to go ahead and type in active because it is the upstream switch, right? So now that we've done that, and it's giving us a problem saying that gig 03 is not compatible with gig 1. So we will just double check. Do show run interface gig 0/3. And we'll look at gig 0/1. Interesting. Oh, I see why. Because I've got no negotiate turned on here. Let me go into switch port, no negotiate. And then I'm going to go ahead and shut these interfaces down real quick. So that will clear any errors that might have been there. We're going to clear them out. We're going to type in no shut again to bring them back online. And that should bring up the port channel. It said LACP is currently not enabled on the remote port. And that's fine. So if we do show ether channel summary, we're going to see that LACP, they're currently in suspended because the other side is not configured. If we come over here to this side and we go to global config and we do interface range gig 0/0 and gig 0/3 on this side for LACP and type in do show run interface gig 0/0, I'm going to basically type in these few commands right here and type that in, and that's going to get them all on the same page. And do show interface trunk. We can see that the trunking configuration now is squared away. We're going to go ahead and type in the channel protocol is going to be LACP, and the channel group will be 46 of mode of passive. So we're going to basically wait for the other side to kick it off. So now we've created that, which is what we wanted to do. The port channel is created. It was selected. 3 and 0 were selected. And now we can see information going back and forth. And this is a lot of just information that's going to be sent back and forth until these guys are squared away. If we go back to switch 34, we can see that the connection is now up. If we hit the up arrow again, we can see that both ports are now are both now in the port channel, and switch 36 will begin. It's now done doing its communication back and forth, but we can see the details in the outputs as we were going through. So what you're going to continue to see now. So what you're going to see now as we proceed is just going to be a bunch of hellos going back and forth. This is the active communication going back and forth to detect whether or not a link is down or not. So we have that. So I'm going to go ahead and I'm going to undebug, exit out here real quick. So what I'm going to do is I'm going to, well, unfortunately I had to wait for a domain lookup to happen, is I'm going to go on 35 side real quick, and I'm going to configure this for port aggregation protocol. So interface range gig 0/1 through gig 0/3, and then I actually had to do a comma and not a dash because we're not doing consecutive interfaces, we're doing discontiguous interfaces. I'm going to type in here a channel group of, channel protocol of PAGP, and then the channel group of 56, and I'll type in here mode of, and we're going to choose desirable. So go ahead and form a PAGP connection if out of the gate. So we're going to just type in desirable and hit the enter key. And it says range command cannot be done on that one. Let's see why. Do show run interface gig 0/1. Oh, because it's shut down. So let me type in no shut those interfaces. And it may have something to do with the maximum amount of groups. Okay, so interface is now up. Let's reapply that command again. Why is it giving me a hard time? Let me do this. Channel group. Let's try 10. And then mode of PAG desirable. There it goes. Maybe you just couldn't use that particular number. So now it's going ahead and allowing it to be created. And we're going to go down to switch 36. And I'm going to go ahead and type in undebug the LACP events and the packets, because we want to be able to see the PAGP coming across, right? So that's going to turn off all, I'm going to, undebug, I've turned, but do we show debugging, we'll see that debugging, only PAGP is turned on. So we're going to go on this side here and type in interface range gig 1/0 and gig 0/1, and we're going to type in the do show run interface gig 0/1, and I'm going to go ahead and paste this command right here onto both switches, and both interfaces. So do show interface trunk. Now once 46 is good now, and we got gig 0/1 and gigs 1/0, I'm going to type in the channel group, or the channel protocol is going to be PAGP, and the channel group will be 10 with a mode of auto. So whatever is detected. So I'm going to do auto and hit the enter key, and then we should see some information coming back and forth here in a couple of seconds. As soon as the connectivity goes back and forth, we should see some details going back and forth. So there it goes. So we see the information going back and forth, and we should see the interface come online here momentarily. Give that a couple of moments. So on 35, we can see that the port channel is up, which is what we want. Do show ether channel summary. We have PAGP up. We go over to switch 36, and we do show ether channel summary, and we see that PAGP is also up and working. So what this means at the end of the day is that the debugs actually don't really matter, right? I'm just showing you them just to let you know that you can leverage them if you want to understand basically some of the behind the scenes. Maybe you get asked a question about a some sort of detail with that, a TLV value, a type length value, or something along those lines, just so you can see them having been done. Beyond that, really no other value to it than that. So as a matter of fact, let me go ahead and type in do undebug all, so we can turn all debugging off, because debugging is a wear and tear on the CPU. So, but at this point in time, we have our port channels deployed, and that's really what I wanted to get done in this particular video, is show you guys how that process works. So with that being said, ladies and gentlemen, that is port channeling. Beyond that, there's really not a whole lot more to layer 2 that we can dive into. So we're going to start transitioning now into the layer 3 mode and getting all of that stuff squared away. I want to thank you guys for hanging out with me in this particular video, and until next time, guys, take her easy.